morning all. I am Andrea Joseph, QAQC faculty in Techshore Inspection Services. Today let's discuss about the topic Rebar Locater. A rebar locator is used to find the proximity as well as the orientation of reinforcement steel bars in the concrete surface. The instrument mainly consists of a cover meter. It may be battery operated or mains operated. And this cover meter consists of a search head, an electronic meter as well as an interconnecting cable. First of all, we move the search head over the concrete surface and the readings are directly got from the electronic meter provided. Coming to the principle of this instrument. These cover meters can be run either by eddy current effect or electromagnetic induction effect. These cover meters using eddy current effect are more sensitive to the ferromagnetic materials present in the vicinity of the concrete search head, and they are used at higher frequencies, that is greater than 1 kHz and all. And these cover meters using electromagnetic induction effects are used for lower frequencies of less than about 90 Hz, and they are less sensitive to the ferromagnetic materials in the vicinity of the search head. Now coming to the principle. This cover meter using eddy current effect consists of a search head, and the search head forms a magnetic circuit with a reinforcement bar embedded in the concrete. And this search head sets up some eddy currents in the circuit, and the change in the measured impedance is measured. From this we get the required values directly from the meter reading. And coming to the cover meter using electromagnetic induction effect, it's similar to the working of a transformer. It consists of some coils which can be termed as primary coils, and some other coils can be used as secondary coils. These primary coils carry the driving current as well. Then the secondary coils pick up the voltage transfer through the magnetic circuit developed between the reinforcement bar and the search head. Whenever there is a presence of ferromagnetic materials in the vicinity of search head, the magnetic field intensity increases, which in turn increases the voltage, and this is picked up by the meter after amplification is shown in the meter reading. This is how we get the values like orientation of reinforcement bar, then the clear cover, the diameter of the bar, and as well as the depth at which bar is embedded within the concrete. This method has numerous applications in quality control techniques. That is, they can be used to determine the orientation of reinforcement bar after concreting, and they can also be used as a prior test to some other tests like ultrasonic pulse velocity testing, etc. And they can also be used to find underground steel joints, lighting conduits, metal pipes, etc. Even though this can be used for some quality control techniques, they have so many limitations such that they are very slow and labor intensive technique, and they can't be used for too much congested reinforcement area, and also their accuracy will be affected by the roughness of the surface. Sometimes interference effects due to metallic window frames, steel joints, etc. also affect the reading. This will all things will affect the accuracy of the instrument, and this instrument need to be calibrated either in the site or any standard calibration technique. For standard calibration, we use a concrete cube of known size within which reinforced bar is embedded, as their depth and orientation are previously known. Then move the search head over this concrete cube, and from the readings obtained, compare the readings with the actual values. Thus we can calibrate this in standard manner. It can also be calibrated in the site itself. That is, just move the search head over the concrete surface, and we will get different readings at the cover meter depth. And at each point, drill a hole and find the depth, actual depth, using a depth gauge. And using these values, the calibration chart is drawn and it is compared, and whether the value taken by the Rebar Locater is corrected or not. Thank you.